right now, nothing is touching it. It's just still on the table. And it's a balanced force because the gravity is pushing it down, but the table is just keeping it up. It's not moving anywhere.
Okay, would you give a demonstration of that?
Yes. Right here. It's not moving.
Who can explain what Gassimo told you?
Gravity is pulling it down, and air is pulling it up. But both of them have the same amount of force, so it's staying there.
Okay. Gassimo, is that exactly what you said, or do you want to change anything, or do you agree?
No, I agree.
Okay.
Multiple literacies and project-based learning is all about trying to support kids really learning science to a level that they can use their knowledge.
No.
But in order to support them in using that knowledge, we also engage them in literacy and in learning mathematics. All our units are just rich in experiences where kids can actually get evidence to support the claims they're going to make.
Our new driving question for today: how do surfaces made of different materials affect the motion of our toys?
One of our major principles in project-based learning is that we want kids to experience phenomena and make sense of that phenomena. Well, phenomena, in a very simple sense, are everyday occurrences that happen in the real world that we can explain. One of our projects has the title, How Could I Build Fun and Movable Toys That All Children Can Build and Play With? Some of the phenomena they experience are why things start, stop, slow down, and change direction.
We're going to do a scientific test between some bumpier surfaces and the floor, which is a smoother surface. Before you even touch the toys, you're going to predict. Describe how you think the car will move on each surface. And you're going to write. That means you're going to need to talk to each other, because as a team, you're sharing one idea on this paper. Then that's where the math comes into it. You need to find exactly where the front of the launcher is and start measuring.
In the context of project-based learning, when you have rich questions and a really robust problem space that the children are working in, they're using the literacies of reading, writing, viewing, speaking, and listening.
Edgar, what do you think? What is your prediction about how it will move on the floor and on the carpet?
Nothing on the floor is nothing's gonna stop it because the floors, there's nothing on the floor, and in the carpet there's bumps. So if you do in the carpet, it will go slower because the wheels won't now be able to go up the bumps. Do it backwards.
Okay, now remember that you're going to measure how far that was.
123 centimeters.
So it starts by drawing on students' funds of knowledge. It continues by providing students with a broad range of ways in which they can represent their understanding.
So if I really wanted to promote deep learning, I want to create an environment where kids are discussing and debating ideas. I want to create an environment where they're actually collecting data and making sense of that data and arguing about, do I have enough data? I want to create an environment where they're actually representing, not just, it could be in text, they could write a verbal explanation, but one of the things we do in project-based learning is have kids create models where they explain what's going on through a graphical representation.
Yeah. And then there's another experiment we did with cinnamon and some kind of pepper, and we tried to recognize what they were.
Well, take a look at the model, study it with your eyes, and think about what you would change about the model from what you just experienced. And I would like some reasoning with it and some evidence.
Try to make the nose a little bigger so people can actually see it. The robot doesn't just go to the nose, I think. It also goes to the tongue.
Denise, why do you think it should go to the tongue and the nose?
When we had the nose, I think the nose plug, it was only not helping us because of the blindfold. But in his model, there's no blindfold. So it also has to go to the tongue so he can smell it and
taste it.
So just in that sequence, we see the use of various literacies, right? Representing something on a piece of paper, standing up in front of a class and explaining your model to someone, children in their class talking to the person who is presenting, and then that person providing a response back. Blending those different ways of learning is how you really can develop deep knowledge of what's going on. And it's that kind of environment in our units that we really try to foster.
Equity for this program actually encompasses different understandings of equity in the field. Every student has a wealth of intellectual resources that they get from their home, from their community, from their linguistic background, and often in science we're used to soliciting the one that feels most aligned to what we typically think of as science.
Oh, that was the major earthquake in Mexico in 1980. Do you remember what year it was?
Yeah, in August 8 in 1987.
1987. And was your mom living in Mexico City? Did she tell you? Do you remember how old she was?
She was, I think, 10 or 11 years old.
So how do you think that makes her feel now? Did she share?
She feels sad because her house that she lived, she just got it like a few months later that the earthquake passed.
Who remembers what we learned? And can anybody ask Nancy a question about the recent earthquake or relate it somehow to the old earthquake?
How did your mom feel when she felt the earthquake coming?
We need to make sure that our curriculum has prompts within it that are asking for and specifically valuing other resources that can be solicited for making sense of a phenomenon. There are culturally relevant practices for students and teachers where the kids take on the teacher's attitude that whatever somebody's going to say is going to be useful for sense making.
Why do you think that's different for humans and some of these animals? Why would we have such different eyes? Can anyone build off of some other comments we heard? What do you think?
Probably the chameleons, they need more food, or they've developed that structure so they can find food easily.
Does anyone want to add to that or say anything slightly different? Or say something in Spanish?
Que un peregrino es diferente porque él es un cazador, pero él observa su presa antes de ir hacia ella. Él observa sus movimientos y cómo es, si puede ver de un lado, si no ve del otro, para buscar el momento exacto para cazar a la presa.
Yeah, who had the eagle? Did anyone have the eagle? What did you think? What about what he just said? Are the eagles similar?
The eagle can see far away.
The world in which children are going to learn in isn't just going to be, I have to recall a fact or just do something repeatedly. They're going to have to develop the world in which they learn. And the kid who can manipulate and design and change their environment by using knowledge is the kid or the children who are going to succeed in this world.
doing.
And so that's what we're trying to get kids to do. We're trying to get them to use their knowledge so they can make sense of things, new things that happen to them.